Hello students, and welcome to this video on implicit differentiation. So far in your calculus class, you've probably been focused on explicit functions. When I think of an explicit function, I'm thinking about something that is in the form of y equals 3x minus 5. So that means that variable y is explicitly written as a function of x. But now I want to move forward and deal with implicit functions. So with an implicit function, we're going to have to do some assuming because our function is going to be written where our two variables are on the same side. We're going to assume that y is a differentiable function of x. So one thing that you want to be able to do is to be able to differentiate each in respect to x. So let's say that I'm looking at the value 3x squared. We already feel comfortable on how to find the derivative of this. If this is my f of x and I now want to find my f prime of x, I utilize the power rule and I get 6x. So nothing new there because I'm just finding a derivative value. Now let's say I have 2y cubed, and that represents my original function. And now I want to find the derivative of f of x. I'm going to utilize my power rule, as always, 6y squared. But because I'm taking the derivative in respect to x, and there was no x here, I have to add on something else, or I guess I should say multiply on something else. I'm going to notate that I took the derivative of y in respect to x. So that dy dx is going to be very, very important. Let's say that I start out with the function. Sorry, that was my alarm to take my vitamins. Let's say I start out with the function x plus 3y, and I want to find the derivative of that particular function. So for the very first term, because this is an addition of a binomial, an x term, and then my 3y, I'm going to utilize my power rule for the first term. It is just x, so the derivative of that is 1. And then the derivative of 3y is going to be just 3. But again, because I took the derivative in respect to x, and I actually found the derivative of something with a y, I'm going to put dy over dx. Okay? And looking at one more, let's say I have xy squared. This one's a little tricky, right? Because this is actually product rule. So I'm going to go off to the side. I'm going to do my f prime, my g, and my g prime. F is x, so f prime is 1. G is y squared, so g prime is 2y. dy over dx because I took a derivative in respect to y. And so when I put this together, product rule says f prime g plus f g prime. So that's 1 times g, which is y squared, plus f g prime is 2xy dy over dx. Now, when you're doing implicit differentiation, a lot of times you're going to be asked to evaluate or look for dy over dx. So not only are you going to find the derivatives as you did here, but you're actually going to want to solve for dy over dx equals what? So I want to make sure I do some problems like that for you. So for example, let's say you are asked to find dy over dx, and you'll have various functions. So let's start out with the function y to the third plus y squared minus 5y minus x squared is equal to -4. So if you're jotting notes, step 1 is literally to differentiate both sides in respect to x. So this is going to be 3y squared dy over dx plus 2y dy over dx minus 5 dy over dx minus 2x is equal to 0. And step 2 is to collect all the terms that have a dy over dx, so that term, this term on one side, and move everything else to the other side. So that's going to have 3y squared dy over dx plus 2y dy over dx minus 5 dy over dx. And I'm going to add 2x to the other side. I then notice that because each term has a dy over dx, that actually is a greatest common factor, a GCF. So I can take out dy over dx and multiply by what's left over, which is 3y squared plus 2y minus 5. And all of this is equal to 2x. And if I want to isolate dy over dx by itself, I'm simply going to divide out my polynomial of 3y squared plus 2y minus 5, and now I have found the value of dy over dx. Okay? Let's do one more example just to make sure you're feeling comfortable. So let's say we have y squared plus x squared minus 2y minus 4x is equal to 4. This is going to give me 2y dy over dx plus 2x minus 2 dy over dx minus 4 is equal to 0. I notice that this term and this term both have a dy dx, so I'm going to keep those on the left. And I'm going to move over all of the other terms, so positive 4 and minus 2x. I'm then going to take out my GCF of dy over dx, and that's left with 2y minus 2 is equal to 4 minus 2x. And then to isolate dy over dx by itself, I'm going to have 4 minus 2x all divided by 2y minus 2. Now you should be able to see that you can actually simplify this further because there is a GCF in the numerator of 2 and there's a GCF of 2 in the denominator as well. And when I have the same number on top and bottom, these can actually cancel each other out and I can be left with a final answer of 2 minus x all over y minus 1. And this is equal to dy over dx. And I do encourage you to always simplify. As always, I hope you found this video on implicit differentiation helpful. If you have questions or concerns, please don't hesitate to reach out.